Okay, let's start. Good afternoon, everyone. Today, I have the pleasure to introduce you to Kyunghyun Cho, one of the inventors of neural machine translation. Cho has been speaker in LXMLS for the last 5 years, I believe, and is an associate professor of computer science and data science at New York University, a SciFar associate fellow, and recently co-founder of a new company dealing with deep learning for protein design, if I understood correctly. Until recently, he was a research scientist at Facebook AI Research, and before that, he was postdoctoral fellow at University of Montreal with Joshua Bencher. So I hope you like his talk. I really like them every time. So you have the floor.
Well, thanks for the generous introduction and the pressure that you have just put on me. This is a kind of second time I'm giving this particular talk, and then this is not really the usual talk that I give, but you know, I believe it's going to be a very interesting talk for many of the students who are participating in this summer school, because LXMLX has a very strong, let's say, emphasis not only on the algorithms themselves, but also on the problems themselves, and also when it comes to problems in machine learning. It's all about data. So you probably have learned a lot about the different problems and then different data sets that are associated with it over the lectures as well as the labs. And then today I'm going to tell you about what kind of efforts are needed in order to build this kind of benchmark suite when you're trying to build them from scratch. So this is an effort, we call it Korean language understanding evaluation, or the building the Korean language understanding evaluation benchmark suite. And then this is the kind of effort that was done by more than 30 researchers in Korea together with me. And then it's taken us about 8 to 9 months in order to complete the entire project. And this project is still ongoing in some sense. I'm going to go through what were the things that we had to do in order to get to this stage, and then what are there, and then what needs to be done further in order for us to get better and better at building a better benchmark suite, and also to cover as broad set of languages as well as the problems as possible. So one thing I want to talk about is that it's really important for us to think about building data sets, and not only about building new algorithms or building the state of the art or whatnot, because there is a huge discrepancy at the moment between the language users, or the number of language users, and the content availability for each of the languages. So if you just go into the Wikipedia, search for the languages used on the internet, then what you notice is that there's a huge discrepancy in terms of the content that is available on internet, in terms of which language they are written in, versus how many users or how many language users we have on the internet. So for instance, if you look into the languages on the internet by contents, English is like super majority there. And then we do have, let's say, a bit of, let's say, I don't know, Russian. I'm sorry, I do have a phone at home, weirdly so, in 21st century, and then somehow it's ringing. I just turned it off, my bad. And then you do notice that there are quite a few contents coming out written in European languages, and then there are a few in Chinese, and then the others. But if you look at the languages on the internet by users, of course there are a lot of English speakers, but that's only about a quarter. And then we do have, let's say, about 20% of the internet users who speak Chinese as their main language. And then in fact, the quarter of the internet users, when we count by languages, they speak languages other than all those top, let's say, 10 languages or whatnot. So what that means is that there is a discrepancy in terms of the availability of the content on the internet in terms of language, and then the users on the internet according to language. What that means is that it's actually not that too different from when we look at the resource availability for natural language processing as well as machine learning. So that's a problematic one. So we really want to be able to know how to build a benchmark suite for a new language rapidly, so that we can cover more and more languages. Thereby, we can cover more and more users on the internet who can benefit from these machine learning driven natural language processing systems. Now, one of the things that people have been doing in recent years, well, thanks to the advances in machine translation, is to simply translate existing corpora into a new language. And then that's really nice, because we can largely do so automatically by taking a state-of-the-art machine translation system and translating every single examples you see on the existing corpora. And then we can often use professional translators to translate some of the small set of the validation and test instances, and then they can actually serve as a gold standard, let's say, test examples. For instance, and then there are a few examples like that. XNLI is one of the representative examples where Kono in 2018 translated the Stanford Natural Language Inference dataset into multiple languages using the mix of the automated and professional translations. And this, and then it was done into 15 languages, and it's become a very nice standard that people have followed in order to build up other resources for other languages, in recent years. Now, there are obvious advantages because assuming that the translation is perfect, there is no discrepancy between the original and new corpora that allows us to really compare these machine learning or the NLP systems across different languages at a very fine-grained level. So we can look at individual examples, and then that example is going to be translated into multiple languages and also exists in the original language. So we can see whether there is a difference in terms of the languages across the languages in terms of the, let's say, machine learning algorithms and whatnot. So this is really nice. And then any kind of strength that we have in the original corpus automatically transferred to this new corpus or the newly translated corpus. However, at the same time, there are very clear disadvantages as well. One is that there are cultural social discrepancies between different languages. And then these cultural and social discrepancies cannot be overcome by simply translating the original corpus. And then the second thing is, in particular, when we think about the translation itself, there is always the big kind of, let's say, perceived discrepancy between translation is a text that is written as a result of the translation versus the actual natural language. In fact, if you look at the Wintner's tutorial at Calling 2016 about translation is, you can find a lot of interesting examples, and then how we can identify all those differences between translation is and natural language. And then the conclusion is that the translation is not necessarily natural language. The last disadvantage is that of course, the strength of the original corpus transfers directly to a new corpus, but at the same time, weakness of the original corpus transfers to the new corpus as well. Especially if we use the original corpus that was created a long time ago, then all those, let's say, so-called bad practices back then are going to be applied to this newly created or newly translated corpus as well. And then there's no way we can, in fact, proactively address those weaknesses. So we wanted to see if we can actually build it from scratch. And then building it from scratch is pretty nice because we can really accurately reflect the social and cultural norms of target language speakers. And then also we can use the best practices of data construction known so far. So these two are very important advantages that we get out of building the benchmark suite from scratch for a new language. Now, there are obvious disadvantages that you probably have already noticed. One is capital intensive. We need to purchase or source corpora. We need to annotate often manually all those different corpora for the different problems. And then it's very capital intensive. And I'm going to tell you a bit about how much capital it took for us to build this entire benchmark at the very end of this talk. And then two, it's labor intensive. Annotation must be done manually, largely, in particular for a new language. And then there's a lot of effort that needs to go into ensure that the quality of annotation as well as the quality of the corpora is maintained at a high level. And then to do so, only way we have found so far that works well is manual inspection. And then this is extremely labor intensive work. And as you see, it's involved, let's say, more than 30 researchers, but on top of that, we had about 50 to 100 engineers in total working on various crowdsourcing platforms, as well as the manual inspectors. But we decided to go for the from scratch route in order to check how intensive labor as well as capital building up a new benchmark suite is for a new language. And then we thought this is going to help us build up a manual that can be used for others when they are building a new benchmark suite for their own languages. And we decided to choose Korean just because 30 researchers who work with me all speak Korean, and most of whom are also in Korea as well. And Korean has more than 75 million native speakers, mostly in South and North Korea, as well as a part of China. And it's considered language isolate, so it's a Koreanic and then Korean, that's about it. Now it has a very unique writing system called Hangul, which is written on the center of this slide. Although there are more than 70 million speakers, in terms of the actual resources for natural language processing as well as machine learning, you can imagine a language with zero resource. There are some resources that have been built sporadically over time, but none of them are standardized, and almost always none of them is accessible outside Korea because of the various, let's say, copyright issues, licensing issues, as well as Korean government being very rapid at adapting new IT technology, without thinking about the backward compatibility. So a lot of the resources that were hosted by the government-run, let's say, organizations do get lost on the way. So we thought that this is the perfect opportunity for us to test this idea of building a new benchmark suite from scratch for a new language using Korean. Enough speakers, meaning that there are a lot of people who can actually assist us in building up this benchmark suite, and there is no large-scale benchmark suite that can be readily used for the Korean. So we were more than 30 researchers from 12 organizations in Korea, and then we had to get 11 sponsors. Some of them were financial sponsors. As I said, it's a very capital-intensive job. Some of them were compute sponsors. It's very compute-intensive because we had to provide a very good set of the baselines. And then few were data sponsors as well, because data does not grow out of nowhere. I mean, we had to carefully curate data based on which we built the benchmark suites. And then this whole effort was led by two people. As everyone knows, however many researchers there are for each of the project, there are always one or two people who actually lead the project. And then those were Sungjun and Jihyung from Upstage AI. We had 4 principles we followed. First one was accessibility. We wanted to make sure that the KLUE is openly usable by all, including academia and industry. And then we wanted to ensure that the KLUE facilitates future advances, meaning that we wanted to make sure that KLUE, people are allowed to build derivatives out of KLUE, so that later in the future, they can add in more annotations or increase the size of the KLUE as they see fit for their purpose in the future. The second principle was diversity. We wanted to make sure that we cover diverse aspects of language understanding, and as well as the diverse topics and styles. It turned out that it's actually not that trivial to ensure this diversity in terms of the aspects of language understanding, topics, and styles, just because the resources that are available openly, because we wanted to hit accessibility as well, are often very skewed toward a particular styles of writing, particular topics, and whatnot. So I'm going to go through each one of them more carefully down the road. And we wanted to ensure that the annotation we provide together with the actual text is accurate. So often what happens is that there are a number of resources out there that are really nice in principle. However, when you look into the actual annotations and the actual text, the annotations are way too noisy or often ambiguous, to the point that we can't really trust the accuracy or whatever the metrics that we compute on those annotations beyond certain level. And in the case of KLUE, we wanted to make sure that we build a benchmark where we provide evaluation metrics, or we provide the users a way to evaluate their systems in the most unambiguous way as possible. Finally, you must have realized or noticed in recent years that a lot of, let's say, large-scale corpora that we have been using do contain contents that are undesirable, both socially as well as for individuals as well. So we wanted to make sure that we deal with this issue of safety by proactively handle the social biases and toxic contents at the time of content or the dataset creation. So I'll just go through what we did to build KLUE based on these 4 principles, and with the 30 plus people, together with the 12 or so sponsors. The first thing we had to do was to ensure that we build a benchmark suite that consists of the diverse set of the problems or the tasks, because this diverse set of tasks corresponds directly to a diverse set of the aspects of the language understanding that our benchmark suite can test. So we added some single sentence classification tasks, such as topic classification as well as relation extraction. And then these tasks check the ability of capturing the semantics of text or the short snippet of text. And we added 2 tasks that are on multi-sentence classification. They are semantic textual similarity and natural language inference. So these tasks check the ability of capturing relationship among multiple sentences by our natural language understanding system. We added 2 tasks that focus on tagging, named entity recognition and machine reading comprehension. These 2 tasks check the ability of identifying important portion of text in the context of a target task or a given context. We added dependency parsing as well in order to check whether our system is able to capture the relationship among the words within text. And then we often refer to it as advanced tagging among ourselves. We added dialogue state tracking because we wanted to ensure that our benchmark can be used to check the ability of our model, the future natural language understanding model, in capturing the relationship across multiple utterances in the context of information collection. This is kind of, let's say, advanced tagging as well, but we separate it out from the dependency parsing because dialogue state tracking involves the multiple utterances that are highly dependent on each other. We actually left out generation, although generation is one thing that I like most because there were a number of challenges that we just couldn't overcome immediately while building this benchmark suite. First one was evaluation. How do we properly evaluate the quality of generated text? So the third principle, if you recall, is that if we wanted to provide an annotation that is unambiguous and accurate. Now, when it comes to generation, however well we annotate the corpus, we know that there will be some ambiguity that is left just because we can get only a small number of the annotations or the target generated text. And second one that is very related to this evaluation issue is the annotation issue. What is the right way to collect a diverse set of text per instance? And then this is actually, this turned out to be very difficult. So we tried some pilot studies in generation or the asking annotators to provide some generated text. It turned out that it's not easy for us to ensure that the annotators, let's say 3 to 5 of them, are going to generate a diverse set of text that's going to cover many different aspects of the generated text. So we had to give up on adding generation, but hopefully in the future, we'll be able to extend this current version of the benchmark suite into the KLUE 2.0 that includes generation as well. So on the right side of this slide, you see the 8 tasks that were included finally in this KLUE, the benchmark suite. So let's just see, if we do hit all these, criteria we had. So one was that we wanted to make sure that we cover diverse aspects of language understanding. We had to give up on the language generation, but we do believe these 8 tasks actually do cover many different aspects of language understanding. And then we also wanted to ensure that the task formats are diverse as well. We all know that the same problem can be described or framed into a different, let's say, formats, and then those are going to require different solutions. So already at the time of the benchmark task selection, we wanted to ensure that it actually includes many different task formats. So we have sentence classification, we have tagging, we have, let's say, graph induction or the advanced tagging, we have the slot filling. So it feels like we have covered a pretty diverse set of task formats. And in the case of the evaluation, we wanted to make sure that there is some objective evaluation, there exists some objective evaluation metrics. And then as far as we can tell, for all these tasks, let's say somewhat objective evaluation metrics exist, and then we have been able to come up with a set of at least one objective evaluation metrics that people can use in order to evaluate their systems. I'm going to go over some of them later in the talk. And in the case of the annotation, the target has to be unambiguous. Of course, some of the tasks turned out to have ambiguous targets or the ambiguous answers. We actually removed most of those instances that have the ambiguity in how the instance can be answered from the very beginning, so that for the purpose of evaluating your any kind of natural language understanding system, using this benchmark is not going to give any ambiguous, let's say, the answer or the evaluation, but it's going to always give the users a very unambiguous measure of how good their, let's say, understanding system is. Now, we thought that, okay, once we decide on the task formats and then tasks themselves, we'll be able to just tackle one task at a time independently in parallel and then finish off the entire project within about 2 to 3 months. We couldn't have been more wrong. So we had to actually start by curating source corpora. That is, we were not going to simply ask each people who is in charge of each task to go out there, collect their own corpus. We wanted to ensure that we are going to provide a source corpora from which, based off of which, they can build up the task-specific corpus and then annotate the task-specific corpus. This was needed in order to ensure that whatever we create is accessible publicly and openly, and also admits the creating derivatives in the future. So we went through a lot of different corpora and then selected a small subset based on the following criteria. First, license. Is it publicly available? Is it publicly accessible? And does it allow future users to derive different, let's say, corpus based on them? Second, domain. So do they actually, what kind of domain is it from? Is it from news? Is it from, let's say, reviews or whatnot? And the style, is it formal or colloquial? Or is it modern or is it classical? So Korean language, when you look at the written text, it's mostly modern. I don't think there is large enough resource that is not modern, but it turned out that there are a few corpora that are available out there that are very classic Korean. And we had to ensure that we don't really include those classic Korean that is really never used anymore these days. And then the fourth criterion we looked at was the ethical risk. And I'm going to go into this ethical risk a bit because some of the corpora that we have identified turned out to have a lot of toxic content, and we wanted to ensure that those toxic content is not included in the benchmark. And then the final consideration was the volume and size. If any of the corpus was way too small, then we thought it was not worth our effort in order to include them in this set of source corpora. Let's look at some of the examples. So we looked at the news headlines. So it turned out that we couldn't really use the news as they are. However, we could use the news headlines because headlines turned out to have no licenses. So we could just use the headlines however we want. We could release the headlines however we want. Of course, the domain is from news. That's fine. Style is formal and modern, although they are often not well-formed sentences. Ethical risk is pretty low. It's news headlines, not those the yellow media, but from the kind of well-established newspapers in Korea. And then when it comes to volume, it's very large. So we decided to include it. Now we found a large corpus of text from the National Assembly in Korea, minutes of the National Assembly in Korea. Of course, it's the National Assembly, so it's public domain. We can use it however we want. The domain is a bit limited. It's all about politics. Now, style is a bit more colloquial than formal because it's about how the politicians actually talk to each other, and then the language that is being used is very modern. There are a bit of ethical risks there because it turned out that a lot of the politicians from a certain party in Korea do talk about let's say a lot of issues in a way that is pretty unacceptable generally, but they do tend to talk a lot as well. So there were a bit of an ethical risk depending on what kind of topics were discussed at each on the day of the discussion. Volume is pretty large, because it's a minute from the National Assembly, so they had to write down every single discussion that went on at the National Assembly. But we ultimately decided to exclude it because of the narrowness of the domain and because of the potential risk involved in releasing this and using it as the corpus to train natural language understanding models. We just didn't want our natural language understanding models to talk like the Korean politicians. Wikipedia. So the Wikipedia is in many different languages, of course, depending on which language we're talking about. The quality as well as the quantity vary quite a bit. Korean Wikipedia, unfortunately, is on the side of the low quality, low quantity. However, we did look into it. Wikipedia is pretty much perfect in terms of licensing. It is released with the CC by SA 3.0, so it does allow us to use it for the various purposes and also allow us to create derivatives out of it. Domain is Wikipedia, or can call it encyclopedia. Style is relatively formal and it uses only the modern Korean. almost no risk in ethics in this case, because the Korean Wikipedia is not really active. What that means is that there is no like the crazy war going on sensitive topics, at least on Korean Wikipedia. And when it comes to volume and size, relative to other publicly available corpora in Korean, this one is actually pretty large. So we decided to include it. This is one interesting corpus, and then I think you might want to look into it for building your own benchmark for your own language, is the reviews from Airbnb. It turned out that Airbnb releases their reviews with a license that is CC0 1.0. So we can actually use them however we want. And obviously the domain is a bit narrow in the sense that it's all the review on the, like the Airbnb properties. And style is extremely colloquial, but the good thing is that all the language that is used on Airbnb reviews is modern. It's almost by definition. No one is going to write a classical Korean to write the Airbnb reviews. It turned out that there are some risk involved in using Airbnb reviews because people did mention a lot of the person identifying information there with, a lot of, let's say, complaints about those people as well as the locations. So we perceived that there were some risks, but that this was a kind of risk that we could actually handle almost semi-automatically. So we decided to include the Airbnb reviews. Another review data that we found was the Naver Entertainment News Review. Naver is one of the largest internet service provider in Korea. It's like the Google of Korea, according to them, but it's a bit different. And then they do have a very large news service where there are a bunch of reviews that are being aggregated from various places. And then the Naver actually released the entertainment news reviews at some point under the license CC by SA 4.0, which is perfect. Unfortunately, we decided not to use this because a lot of contents in this entertainment news, as you can guess from the fact that it's entertainment news, were not really appropriate for really any purpose. We did not want our natural language understanding system to be trained on and evaluated on how people behave when they talk about the, let's say, celebrities in Korea. So we decided to exclude it, although the volume was pretty much the largest among the source corpora that we have considered. And then we go on, but at the end, what we ended up with was the lack of, let's say, well-written text. So Wikipedia is reasonably well-written, but it's not too large, and it's a very static text. It's like encyclopedia. And then there's nothing that is, let's say, well-written about it. It's just, the very plain text. We had Airbnb reviews. The volume is high. It has a lot of interesting content, but the text is not necessarily well written. It's just like, the people casually writing reviews. We couldn't really find any publicly available, well-written text. So what we did was we actually contacted a bunch of newspaper organizations in Korea in order to see if we can get access to some of their news articles and then release it as part of this benchmark suite. Every single one of them said no. Every single one of them said no, except for the Korean Economic Daily News, which is one of the major newspapers in Korea, which, they released some number of their articles, actually quite many articles, for the purpose of research, for the research purpose to be included in the KLUE under the license CC by SA 4.0. And then this actually helped us getting get the diverse set of topics as well as the writing styles, when building this KLUE data set. And then it was, let's say, well written, all written in modern Korean. There was almost no risk involved in, let's say, ethics or whatnot. And then the volume and size was pretty large. So this was actually one of the last steps that we have to take in order to ensure that we get a good set of source corpora based off of which we can build a benchmark suite. So at the end of the day, we reviewed about 20 or so potential source corpora, and then we ended up with the 10 source corpora, all of which are openly usable, available, and modifiable. And it took us a bit more than we anticipated in order to just curate this source corpora. Now, once we have curated this set of source corpora, we had to clean up the source corpora because it's not all news articles. A lot of them are from Wikipedia, a lot of them are from the reviews, and a lot of them are from essentially the internet, meaning that there are a lot of non-text characters in the source corpora. So we removed hashtags, HTML tags, incorrect Unicode characters, empty parentheses, and consecutive blanks. We removed any sentences with more than 10 Chinese, Japanese characters. It's probably the artifact from more of a classical text that you see in Korean, but in modern Korean, no one actually uses Chinese or Japanese characters in Korean sentences, so we just removed most of them. And then we also removed the templated parts from news articles and Wikipedia articles, such as the copyright marks and so on. Again, as long as this was allowed by the original license. We also removed the toxic content by automatically detecting hate speech as well as the gender bias. Of course, it's an automated detection, so it's not perfect, but then we did the manual detection and removal in the annotation time using the annotators. So what that means is that we had a two-stage of filtering of the toxic content. One of the biggest issues that arises from using the Airbnb reviews is that there are so many person identifying information in the Airbnb reviews, although by the Airbnb review policy, those are not really allowed. So we largely use the regular expression-based matching to remove the email addresses, URL, as well as any kind of @references. And then most of the others had to be detected and removed manually in the annotation time. So that was how we now curated this source corpora. But then source corpora curation does not tell us how to build the corpus for each of the tasks separately. So we had to actually look into each task separately in order to build the data set and annotate that data set. And what we realized is that every single task is unique. They have a unique task format. They require unique annotation protocol. They require unique cleaning protocols. They require a unique set of evaluation metrics, and they all exhibit unique set of artifacts or so-called spurious correlations that need to be detected and removed when we build this task-specific data set. On top of this, there were more task-specific considerations that had to be made for each and every task. I'm going to just go through a few sample tasks to give you a sense of what kind of considerations that had to be made in order for us to build all these benchmark data sets and their annotations. So in the case of topic classification, we decided to use the news headlines. News headlines are not really like perfectly formed, but it is usually a short sentence. And then the short sentence does tell us a lot about what kind of content or the topic the entire news article is talking about. So we decided to use these news headlines alone for topic classification. So the input is going to be a sequence of tokens, and the output is going to be a single category to which this input belongs, where the input is the news headline, and then this category is to which this entire news article belongs to. Unfortunately, it turned out that we couldn't use the existing category text coming out of the newspapers because a lot of the newspapers tagging is driven by clickbait categories or the, increasing the click-through rate. And then what that means is that a lot of categories are irrelevant to the actual content of the news articles, but they were tagged to attract more clicks from the users. So we couldn't really rely on the existing category text, and then we had to decide on the category for each and every news headline ourselves using crowd workers. And after running a bit of a pilot run after running some of the pilot runs, we selected 13 crowd workers. And then for each and every headline, we collected at least 3 annotations. And then we only kept the headlines where we had the clear majority category. As I said earlier, one of the goals here has been to build a benchmark suite which has the clear and unambiguous annotations, thereby unambiguous evaluation. So we only kept the headlines that have the majority category after annotation. And then we ended up with about 64,000 headlines. And every time crowd worker was given one headline, they were asked to report this headline if it is deemed problematic. And it turned out that there were about 650 headlines with the person identifying information, 194 headlines with toxic content, and more than 2,500 headlines with no suitable categories, which is a bit weird, But this is also the artifact from the fact that the headlines are decided by the editors. And then often in recent years, a lot of editors are very obsessed with the click-through rate. So the headlines can be a bit deceiving or can be void of actual information. So at the end of the day, we excluded about 3,000 headlines after this kind of, let's say, manual cleaning process. Evaluation was a bit straightforward in the case of topic classification. We just use a macro F1 score. And then there were no annotation artifact that we had to worry about based on our analysis. So in the case of the semantic textual similarity, we decided to use 3 source corpora: Airbnb, policy, and ParkQC. So these are the reviews and news articles coming out of, or the press release coming out of the government, and also the is a question answering data, question related data set that we use. So the task format is that the input is going to be a pair of sentences, and the output has to be either a score, real value score between 0 and 5, or it could be either 0 or 1, so the binary. So we consider both cases. For annotation, we get the real value score between 0 and 5. Now it turned out there's a big issue of how to select the subset of the examples that are going to be annotated. When you simply build a random pair of sentences, almost always, if not really like always, these 2 sentences are irrelevant. Oh, I'm sorry. I think this should be irrelevant. There is a typo on the side. And then the issue is that then what's going to happen is that the annotated score is going to be extremely skewed towards 0. And then that doesn't really help. Not only for the training purpose, but for the purpose of evaluation. We want to evaluate whether the understanding system is able to tell whether a given pair of sentences are relevant to each other or they're related to each other. But if all the examples in the evaluation set are irrelevant pairs only, then what can we tell about our language understanding system? So we had to actually come up with a number of strategies in order to make sure that we can build up a pairs of sentences that cover the entire spectrum of the relevance, completely irrelevant all the way to the very, very relevant. And then we use, and then those strategies include round trip translation, some grid matching based on the root score, or even using metadata. Once we sampled all these instances so that we cover as broad spectrum as possible, or the spectrum of the relevance as uniformly as possible, we built up the annotation pipeline. We've started from the SAMeval 2015 pipeline, but we had to make some modification to fit Korean because a lot of the, let's say, details in this annotation protocol from the SAMeval 2015 were quite specific to English. So we had to make small adjustment here and there in order to make sure that the protocol is applicable to Korean. And after some pilot studies, we selected 19 crowd workers. And then these 19 crowd workers annotated nearly 15,000 sentence pairs. And after this annotation, we had to exclude 2 annotators because they were somehow annotating the scores in a way that were simply the opposite of what all the other annotators were doing. And then we ensured that every single sentence pair received at least 5 scores from 5 workers. After these 5 scores were selected, we averaged and rounded to the first decimal point to get the actual target annotation. Now, one thing we noticed was that even after this, let's say, even after applying all these strategies for the instant sampling I described just now, most of sentence pairs ended up being, let's say, irrelevant pairs. So we had a huge peak near 0, and then there was a bit of a peak near the, let's say, 4 or 5. What that means is that at the end of the day, it did look like very bimodal and then looked like the binary classification problem. That's the reason why we actually consider this problem as 2 problems. One is regression, and the other one is classification. So one thing we actually did was that this skewness could work as some kind of artifact that the model can exploit and makes it difficult for us to come up with a good evaluation metric. Because any model that says simply all 0 will be highly scored because most of the examples are indeed annotated with score 0. So what we did was to keep the training distribution as it is. However, to build the development and test sets, we actually intentionally constructed them so that the distribution over the scores is going to be close to uniform. So the model should be trained on this skewed data set that is a training set, but then will be tested on this uniform, this data set that contains all possible scores in this spectrum of relevance almost uniformly. And for the regression, we use the Pearson's correlation coefficients as the evaluation metric, while for the binary evaluation, where we simply threshold the score at the 2.5 or not, we use the F1 score. At the end of the day, scores were largely bimodal, so my personal opinion is that the F1 score is a better metric to use in this particular case. So that was a lot of, let's say, consideration for this simple task of the semantic texture similarity. But then let's move on to natural language inference, which is even more tricky, it turned out. So in the case of natural language inference, we decided to use Wikitree. That's a kind of, let's say, yellow media in Korea. But the nice thing is that all the news articles are completely open, so we could use a lot of them. And then policy, that was the press release from the government, Wikinews, is another relatively yellow media kind of thing. And then we use the Wikipedia and then a few other data sets for source corpora. Now the task format, you all are probably familiar at this point. We get a pair of sentences, premise and hypothesis. And then given this pair of sentences, the model should decide whether the hypothesis entails premise, hypothesis contradicts premise, or whether these two sentences are largely neutral as any relevant. I still believe that the neutral should not be the class label in this particular problem of the natural language inference, but that's what everyone does, since Sam actually included it, if I remember correctly, in 2016. So we just decided to stick to this. So for annotation, it turned out it's a bit tricky. So what we did was to resample a premise from the source corpora, but then we asked the crowd worker to write a hypothesis, because it was kind of impossible for us to select a hypothesis that's going to either contradict or entail a sampled premise. Doing so required us to be able to solve this problem of natural language inference already. So what we did was to ask the crowd worker to look at a premise and then write a hypothesis given a target class. So we asked the crowd worker, here's a premise. Now please write a hypothesis that's going to contradict this premise. We ask the crowd workers, here's the premise. Please write a hypothesis that's going to entail this premise. And then we ask the crowd workers, given this premise, try to write a hypothesis that is neutral or irrelevant to the this premise. And once we did that, for every hypothesis, we asked multiple other crowd workers to validate whether the premise and hypothesis pair corresponds to the target class that was given as the instruction to the crowd worker who wrote the hypothesis. And then we only kept pairs for which a majority consensus was made. And then we ended up with about 30,000 final pairs that we considered as unambiguous and well annotated. Now, we could actually see that following this, let's say, very well curated or the designed annotation protocol does end up with a better, or the data set with a better annotation. So there is another natural language inference data set in Korea that was released only a couple of years ago. And then when we looked at the agreement rate among the different annotators for different examples, we do see that the KLUE's natural language inference dataset has much higher rate of the agreement among the annotators. Now, of course, it was not designed at once. We had to go through many iterations of refining the annotation protocols until we got to this point at which we were satisfied that the annotations are unambiguous and well done. One of the issues we ran into with the natural language inference, or in fact, not the issue that we ran into, but a lot of people have run into. So for instance, Noah Smith who was a speaker or the lecturer this summer school, identified this issue of the so-called annotation artifact on the Stanford natural language inference dataset a few years back. And then it turned out, however well we designed the annotation protocol, this kind of artifact just exists. that just exists because of is the correlation that appears out of the actual causal relationship there, and then we can't really resolve them. It's just a statistical ambiguity that just exists. So, and then among all those, let's say, potential artifacts that arise from the annotation protocol, one major issue we found was that the hypothesis alone classifier can really be good, because there is a clear spurious correlation between hypothesis itself and the label. So what we did was that after the annotation was done, we trained a large classifier on the hypothesis only input, and then we used this large classifier to build a development and test sets to contain examples that cannot be well predicted by the hypothesis only input. Now, this is a bit controversial, I can see, because this might actually skew the entire training distribution or the data distribution itself. But after doing so, we did some manual inspection, and then we noticed that all these development as well as the test examples actually do look fine to human eyes. Now, I'm going to skip on the relation extraction because for the sake of time, but there are a number of, let's say, things that we had to consider for relation extraction as well that goes way, way beyond what we thought were needed for to build this data set. And then there is a paper on KLUE that is over 70 pages long. So I highly recommend you take a quick look at it to see what were the issues that need to be overcome in order for us to build all these benchmark data sets for 8 different tasks. So one thing that we wanted to make sure is to make this data benchmark suite very useful. And what do I mean by useful? Is that the people need to use it to check the quality of their understanding system, but also to be able to improve our knowledge of the machine learning algorithms itself. And then what is one of the well-known way to do so is to beat the state of the art. And then what that means is that we wanted to provide people with this benchmark coupled together with a very, very strong baseline that they can try to beat, and then thereby try to innovate on some of the algorithms or even the data pre-processing techniques. So we decided to build a very strong baselines. And then to do that, what is the one thing that everyone does is pre-training. So we have pre-trained and have released a very large scale language models that were designed and trained for Korean language. Now, unfortunate thing about source corpora is that because we are being very careful in choosing those source corpora based on the number of criteria that were not really considered or used by many other people who were collecting data before, source corpora, the entire source corpora that we have collected turned out to be quite small relative to the internet scale corpus that is being used these days in order to train this large scale language model. So we constructed a so-called pre-training corpus separate from the source corpora. And then the interesting thing is that in doing so, we try to ensure that we do not remove much of the information, however toxic or the socially undesirable those content are, because we acknowledge in order to build, for instance, hate speech detection module or the socially biased content, in order to build a network that is able to detect hate speech or the socially biased content, these classifiers or the pre-trained models must know about those hate speech as well as the socially undesirable content. So we left them in as much as we can without compromising the, let's say, privacy and whatnot. And then that turned out to be a problematic one. So we can leave the hate speech as long as our purpose is to build a system that's going to detect hate speech in the future. However, the private information is a bit problematic because the private information can be retrieved from this large-scale pre-trained language model and can be used for a nefarious purposes by anybody. So what is the right way to handle this person identifying information or the private person identifying information without making our model blind to such person identifying information? So what we did was to use the idea of the pseudonymization. So we use semi-manual, semi-automated approach to detect all these private informations and use these pseudonymization techniques in order to replace those numbers or those information with some random information that was generated to look similar to a particular private information, but that does not actually contain the actual information that was in the original private information. And then it turned out that doing so actually gets us large enough corpus for pre-training, and then without compromising on the privacy of the actual users who have created all this content. And then we have collected much larger amount of corpora. We don't use this pre-training corpora for building the benchmark datasets or annotation, but we use this only for pre-training a language model that we are going to release. And we do not release the pre-training corpora because we couldn't actually ensure that there won't be any issue of licensing or issue with the copyright. But when we talk with some of the lawyers, they said that releasing the pre-trained models should be fine. So we trained two models, one based on BERT and then the other based on Roberta. Those are essentially the same models, but with the better hyperparameters for the Roberta, with the better loss function, or as in the not doing the next sentence prediction or the adjacent sentence prediction. But we trained these two in order to see if this difference in the performance between BERT and Roberta in English translates also to Korean as well. And then we had to come up with a morpheme-based bypair encoding that is very much focused, geared toward Korean, because it turned out that the bypair encoding as it is, or the morpheme-based segmentation alone, neither of them actually worked well for Korean. And then we compared it to, we also released, or we point to these multilingual models as well as the earlier Korean specific models for the easier comparison. And then it turned out that it's actually important to curate a good pre-training corpora and then use a algorithm that is specific to this target language that is Korean in order to get the best performance out of for all these 8 tasks that we have designed. And then a few things that we have learned. One is that the multilingual models definitely do lag behind, unfortunately, when we have curated a large enough pre-trained corpora that are geared toward the target language, Korean language. And then second, we noticed that using a Korean or the target language specific pre-processing, such as the segmentation here, is really important. And then that is apparent from comparing our baselines or the pre-trained models against the existing Korean specific pre-trained language models. And then the third one is a bit boring one, and I believe that the Slav Petrov earlier said that this is definitely not the only way to go about, but at least on this particular benchmark suite, we noticed that the larger models tend to perform better than smaller models. So scale turned out to be quite important still. And then we are releasing all these pre-trained language models for people to easily download and then innovate on top of these pre-trained language models. So to summarize, I'm almost running out of time. So there are a number of considerations that we have put and then we have stuck to really, really strongly. That is open access. We wanted to ensure that the benchmark corpora were carefully sourced to be released with CC by SA, publicly accessible, publicly distributable, and freely modifiable. And then these properties are the ones that maximize the accessibility and also make this KLUE, the benchmark suite, future-proof, because anybody can take it and then improve upon it and distribute it publicly and freely. We also had to spend a lot of time and iterations cleaning up this benchmark corpora so that what we provide as the benchmark suite is not filled up with all this hate speech or filled up with the various undesirable social biases or with all those personally identifiable information. We wanted to make sure that the evaluation of the language understanding is done on a well-curated, clean, and acceptable speech only. Of course, we couldn't really do so with the pre-trained corpora. That is the reason why we are not releasing pre-trained corpora, but only the pre-trained language models. Now, those pre-trained language, is it correct that the pre-trained language models are not the pre-trained corpora? I think that's a debatable point because the line between the data and model is getting fuzzier and fuzzier every day. But at least this was our minimal effort in order to ensure that we provide the way to facilitate advances by providing the strong baselines without releasing any of these corpora that is filled up with hate speech and various undesirable social biases. And this one I'm going to skip because I just talked about it, the importance of the strong baselines and how we are releasing those strong baselines publicly available, to be publicly available. And then we also have built a leaderboard that's going to serve as an important, let's say, channel to broadcast the progress. And then this is already available. You can go to KLUE-benchmark.com, and then you'll see that the leaderboard is there. You can actually submit your systems shortly in about 2 weeks. So just to tell you what it took to make KLUE is going to be just a 1 minute. It was a huge collective effort. There were more than 30 researchers, and then researchers from various disciplines, natural language processing, machine learning, and also we had a bunch of researchers who are expert in crowdsourcing as well. And these people were from various organizations, some from academic labs, some from corporate labs, and some of them are from the crowdsourcing companies. And we actually needed a very strong support, both from industry and academia. We need the support of the researchers, we need the data support, we need compute support, we need annotation support, and we also needed engineering support. In order to get this, we had to actually contact and collect all these sponsors, and then these sponsors actually provide a lot of different things, including the financial support. What that means is that the building of this benchmark suite is not only just a scientific endeavor, but it has to be a social and collective endeavor. And we were, at the end of the day, it was a very expensive, both financially as well as the labor-wise, and then it was a lot of the iterations that we had to go through. But I can tell you that it can be done for a new language from scratch, and then by doing so, we can get a much better benchmark suite for any new language. Now I think it's time for you to actually build one for your language by asking people for support and spending your own time and effort. I think, and you'll find it that it's very, very worth it. And thank you very much for listening.
Thank you. So I think we have time for a set of questions. We have 14 in the Q&A.
Oh, yeah. I actually see them. I can try to answer some of them or all of them. Let's try this. The most of 40 that's devoted twice. The question is by Janine, and then I'll just read out the question. Am I guessing right that all of your sources are from South Korea? If yes, would there have been sources from North Korea which you could have used? How different is the language style used in North Korea? Yes, this is a very good question. Most of the corpora that we have used, if not all of them, are from South Korea. Of course, in the pre-training corpus, which largely comes out of the crawling the internet, there may be some North Korean text, but it's very difficult to find North Korean content on the internet. There are a few YouTube channels run by the North Korean government or the propaganda actually companies, but the amount of the content there is very, very small. So even if there were, they were probably negligible in terms of the impact it has on the actual corpus. And also there is a pretty large community, about 1 million or so in China who speak Korean language. Unfortunately, again, the content that is being produced from that part of China in Korean is quite limited. So indeed, if I were to be very precise, this is more like the modern South Korean that we have focused on. I hope that answers your question. I'll go to the next one by Lucy. Would there be digitized books or digitized metadata in libraries in Korean that you could use? I'm wondering, yes, this is a great question. Unfortunately, we couldn't use most of the books because of copyright. And then the copyright for each and every book actually extends almost up to 75 years. And then that is a uphill battle that we couldn't actually fight. If you remember, Google, the kind of, all those, legal ordeals that Google Books had to go through, and eventually Google had to arrive at some kind of settlement with the Authors Guild and so on, we couldn't really afford to do so. So none of the books are included. And because the modern Korea kind of started only about 60, 70 years ago, there isn't much of the classical Korean text that we can use coming out of the books that were written a long time ago. So perhaps in about 100 years, our descendants will be able to build a new version that is based on the modern Korean books nowadays. Next question is from Max Mueller. The Korean-specific morphological BPs sound very interesting. Could you elaborate on what makes them well-suited for the language? Yes, this is an interesting question. What we had to do was that we realized that the morphological analyzer for Korean works to a certain degree, not perfect, but not perfectly. And then when we use the byte pair encoding on the raw Korean text, work to a certain degree, but not perfectly. So what we had to do was to use these two, in two stages. So essentially, we use the morpheme analyzer in order to segment the text into the morphemes only to a certain degree, not perfectly. And then we apply the bipair encoding on top of that. And then what we do is that we populate some of the bipair encoding vocabulary with these morphemes so that we don't have to run the morpheme analyzer in the test time, because the morpheme analyzer does have an error. Now, I won't have time to go into all those details, but it is all written down and pretty well documented in the paper. So I highly recommend you to take a look at it there. Let me see. Next question is from Ashutosh. Do you think asking annotators to edit a text might be better than asking them to write from scratch for generation data collection? This one, I don't have any answer myself. I think you need to actually ask a lot of the organizers here who know actually more about, let's say, how to collect all these annotations for the post-editing as well as the generation. I think the Ramon can answer it pretty well. So I'll let you ask Ramon on Slack for this question. Next one from Vanellin. Oh yeah, Ramon, yes, you'll be able to answer, right? As far as I can tell. So I'll let you answer, yes. Okay, so the next question is from Vanellin. Isn't there a risk that selecting examples with completely unambiguous annotation will lead to a dataset that is too simple? This is a perfect question. This is the question I'm being asked, and we're being asked constantly, is that indeed the examples that we filter out because of the ambiguity in the annotations that we have collected are often a very difficult questions or the difficult instances. And does it make sense for us to remove the difficult instances? In our opinion, answer is yes, for the purpose of this particular benchmark suite. If we were actually building a benchmark suite so as to label those difficult instances and then trying to check whether the language understanding models can correctly predict that these instances cannot be answered unambiguously, I think that for that kind of purpose, these annotated examples or the filtered out examples can be quite interesting. But what we were more worried about is that if we have those ambiguous annotations, somehow, let's say, in the development set or the test sets, then the evaluation metrics that we provide for others to use in order to evaluate the quality of their language understanding system becomes also ambiguous. And then that's the one thing that we wanted to avoid. But in the future, that's a great suggestion. We should keep them, but just keep it aside with the separate tagging text saying that these are supposed to be ambiguous examples. Thanks for the extra suggestion. We'll try to take into account in the KLUE 2.0, which is going to be done by a completely different set of people, because all the researchers who worked on KLUE are totally exhausted, and then everyone kind of swore that they'll never create any new resource ever themselves. All right, so there is a question from an anonymous attendee. Did you consider checking and correcting spelling mistakes while cleaning the source corpus? No, we haven't. We actually haven't corrected the spelling mistake. We just wanted to follow as natural way. We want to make sure that our text to look as natural as possible. And then if there are particular spelling mistakes that are very natural or frequently occurring, we wanted to just keep them there. Okay, so the question from Jungwoo, aren't headlines too short to run classification? They're very short, but not always. So that's the kind of caveat that we say. And then as a part of the annotation process, we actually did ask annotators to flag some of the headlines are just not well formed at all. And then we filter them out. So we do end up with for the benchmark, like the test classification purpose, end up with the headlines that are reasonably well formed to a point that we may call them a sentence. Okay, next one. Next one is from the same person. So I'm going to skip to another, let's say, anonymous. Okay, let's skip to the non-anonymous, let's say, attendee. Okay, Ines Pedro. What curating processes were applied to the pre-training corpora besides anonymization? So yeah, besides the pseudonymization, we actually didn't apply much of the any of the curating process for the pre-training corpora. Only thing that we made sure was that they are available at this point in time. But yeah, you're right. I mean, if we wanted to apply more kind of, let's say, criteria for preparing and curating pre-training corpora, unfortunately, pre-training corpora we use are have billions, was it like 60 billion tokens? Not easy to actually inspect them manually or even semi-automatically. So that was the limitation that we ran into. Okay, another question from Elizabeth Eder. Pseudonymization. Did you compare results between models trained on the original? Oh yeah, this is a great question. So whether we compared between the pre-trained language models trained on the pseudonymized version versus non-pseudonymized version. Okay, hold on. Oops. Let me just share my screen just quickly once more. So we actually did. I skipped that slide, but thanks for asking. It's almost like I planted this question, but it's not the case. Let me see. So here, what we observed is that except for NER and machine reading comprehension, there's always a little advantage of using the original corpus. However, that gap is pretty small, and then we think that this pseudonymization is worth trying. Now, interesting thing is that in the case of the NER, we actually do get small improvement by using pseudonymization. And I think this is because pseudonymization kind of breaks some of those spurious correlations that appear between the, let's say the zip code and then the location appearing all together and so on. So I think this is largely task dependent, but our suggestion after running this comparison experiment is that if we could, we should always pseudonymize in order to avoid leaking any of the privacy, let's say, sensitive information from these language models. I can answer two more questions, I guess. One is from Loic. Pre-training corpora, you do not release them, instead release the model. So why would you say this is useful or required to remove PII? So there was a recent paper from University of Toronto showing that you can in fact retrieve a lot of the privacy, person identifying information. So for instance, let's say I have a large language model. I'm going to put the phone number of Kyunghyun Jo is, and then let this language model reconstruct, predict the next word. And it's going to just give me my phone number, for instance, because it's somehow stored in this model at some point. And then by pseudonymizing our pre-training corpus, we kind of make sure that there's no way this language model can figure out, let's say, your phone number or my phone number or my address or whatnot. It's going to know that this some address needs to come or the some phone number needs to come next, but it won't know precisely what the phone number should be. So that is the reason why we think that it's important to remove PII, even though we only release the pre-trained language models. Okay, so the final question that I'm going to answer for now by Hao Xing, I think I know him, yes. The question is, thanks for the exciting talk. Well, you're welcome. Okay, have you tried to take a look at the bias in annotation? For instance, just adding a no in Korean and ally task. If you do, how you work on that? Yeah, this is really a great question. In fact, there were a lot of annotation artifacts that were identified for all these tasks by other people. And also a lot of the annotation artifacts that we could just see by looking at the annotations because we did a lot of manual inspection and iterations. So often we had to try to remove them by identifying them by looking at them manually and then updating the annotation manual or the protocol that we provide to the annotators. And then we went through multiple iterations to remove most of the visible, let's say, artifacts. And then at the very end, in many cases, we relied on a lot of statistical methods and the machine learning in order to identify some of the known, but that are not visibly apparent artifacts from the data set. I hope that answers your question. You can look at the technical report. It's a bit too long, but we did actually write down everything that we did there so that you can easily reproduce the whole process for a new language. I guess I answered most of the questions. Yeah.
You're completely fast answering everything. So thank you very much for your great talk, for sharing your experience. And we hope to have you here again next year, presentially, please. So thank you again.
Please do invite me, right? That's the thing that I should ask, right? Thank you very much for the invitation. And then for all the students, I'll be on Slack for another day or two. So if you have any questions, do leave on the Slack channel. I'll try to answer them as much as I can. Thank you very much.
Thank you.
And good seeing you all organizers as well.
See you.
Bye-bye.